Okay, so how can we go about actually evaluating this model? So we need to compute a few more statistics. They're pretty simple. So this first one we'll call the total sum of squares. Total, I'll just put SS for short, total sum of squares. We're also going to compute the explained sum of squares. And then we're going to compute something called R squared, which is interesting and you should definitely know about it. And so the total sum of squares is going to be actually how much variation there is within that outcome variable. So how much variation is there in being pregnant, right? So we'll just remember how we did that with the correlation. We took the average and subtracted each person's score from the average and then squared that. And then added all those squared numbers up and we got the total sum of squares where there's actually a function in Excel for it. So it's DEV SQ, and we'll open parentheses and we will select all of our data in column V, close parentheses, and we should get 250. We got it. And then for explained sum of squares, well, that's pretty simple. If we have a sum of squared error, that we can just subtract that from the total sum of squares and we should have an explained sum of squares. And so we explained 108 out of 250. And then for the R square, we simply take the ratio of explained sum of squares to total sum of squares. And so we have an R square value of 0.43. And the way people traditionally interpret this, while I've seen a convincing argument by a man who's very talented at this, he told me that this wasn't completely correct, but I have heard plenty of statisticians, data scientists, and other seasoned researchers saying that you can interpret this as a percentage. And in fact, you'll hear that language even in scientific articles. They'll say something like, well, with these variables over here, with this transactional data, we were able to explain 43% of whether or not somebody was pregnant. So that's the percentage of variation explained in the dependent variable by the independent variables. Of course, again, I just wanted, with that caveat, that technically that's not correct. I usually don't say that phrase in my own research papers. I'll just say the R squared value was equal to this, or I'll say, keep the language pretty specific like that.